Welcome to our series on ancient Roman building techniques. Today, we're looking at the material that built an empire, Roman concrete. Before the Romans, builders relied on stone columns and beams, which limited how big and open an interior space could be. But they invented opus cementitium, a revolutionary layered concrete that changed everything. The secret was pozzolana, a volcanic ash that created a chemical bond so strong it could even set underwater. Modern science recently discovered it even self-heals. Lime clasts inside the mix react with water to seal cracks over time. In seawater, it grows crystals that make the concrete stronger over centuries, which is why their harbors still stand today. This allowed for massive, unreinforced structures like the Pantheon, focusing on interior volume instead of just external form. It was fast, cheap, and durable, allowing Rome to pave 80,000 kilometers of roads across the known world. From baths to basilicas, concrete was the backbone of Roman urban life and engineering genius. Next time, we'll see how they mastered the arch to take this material to new heights. See you in part 2. Last time we saw how concrete gave Rome its strength. Today we explore the geometry that shaped its skyline, the arch. Unlike a flat beam, the arch uses wedge-shaped stones and a central keystone to redirect weight downward and outward. This allowed Romans to span much wider distances than ever before without needing constant support columns. Extend an arch horizontally and you get the barrel vault, perfect for the massive corridors of the Colosseum. By intersecting two arches, they created the groin vault, concentrating weight on four corners instead of a whole wall. This structural magic allowed for huge windows, filling massive halls like the Roman baths with natural light. But arches weren't just for buildings. They spanned valleys and aqueducts, bringing fresh water from miles away to the heart of the city. The arch was the bridge to Rome's greatness. Next time, we'll look at its ultimate evolution, the dome. See you then. We've seen the material and the geometry. Now we witness the ultimate result, the Pantheon, the world's largest unreinforced concrete dome. Its design is a mathematical masterpiece. The interior height exactly matches its diameter, creating a perfect sphere of space. To keep it from collapsing, Romans used weight graduation, heavy basalt at the base and light, porous pumice at the very top. The dome also thins as it rises, shedding tons of weight while maintaining its incredible compressive strength. Look up at the 140 coffers. They aren't just beautiful, they remove unnecessary concrete, making the dome much lighter. At the center is the oculus. By leaving the apex open, they removed the heaviest point and created a powerful compression ring. Inside the walls, hidden brick arches act like bridges, diverting the dome's massive weight onto solid support piers. The Pantheon is a 2,000-year-old testament to Roman genius. Next time, we'll see how they paved the world. See you in part 4. Rome didn't just conquer with legions, it conquered with roads. Today, we explore the engineering behind the 40,000 miles of paved highways that connected an empire. The secret to their longevity was a standard 4-layer design, reaching up to 5 feet deep to ensure a stable, heavy-duty foundation. It started with large foundation stones, followed by a structural core of crushed rock and lime mortar, rammed down into a solid mass. But drainage was king. Engineers built the roads with a camber, a curved surface that forced water into side ditches to prevent erosion. Using tools like the groma, Roman surveyors achieved legendary straightness, cutting through hills and marshes to keep the legions moving fast. Milestones were placed every Roman mile, marking the distance to the city and serving as the first true global GPS system. This massive network allowed for rapid communication and trade, creating a legacy of connectivity that we still use today. The roads were the arteries of Rome. Next time, we'll see how they mastered the flow of water in our final episode. See you then. In our final episode, we explore the lifeblood of the city. Rome was a master of the flow, bringing fresh water in and taking waste out on a scale never seen before. From massive aqueducts, water was diverted into a sophisticated network of lead pipes, or fistulae, stamped with the names of owners and makers. But they didn't just move water, they heated it. The hypocaust system used raised floors to circulate hot air, creating the world's first central heating. This technology powered nearly 1,000 public baths in Rome, making hygiene and relaxation the center of Roman social life. And to keep the city clean, they built the Cloaca Maxima, the greatest sewer, a massive stone-vaulted tunnel that still functions today. From concrete to plumbing, Roman engineering created the foundation of the modern world. Their techniques weren't just about building, they were about lasting. Thanks for joining us on this journey through the history of Rome's building techniques. Stay curious, and we'll see you next time.